is a strong acid. How do I know that? Because you're just like looking it up until you remember what they are. That means that its conjugate base is weak. So the question is, which one is the strongest base? My only two bases are my base and my conjugate base. So if this conjugate base is weak, that means that the H2O must be the stronger of the two. Does that make sense? I know that's like 17 steps of thinking. So for letter B, HF is not a strong acid, so it has to be weak. Like it either can be strong or weak. So if it's not on that list, it's got to be weak. That cheerleading hands. So that means the conjugate base has to be strong. So the question, which one is the stronger base? My only options are the base or the conjugate base. And if my conjugate base is strong, that is going to be the answer, okay? But now for this one over here, they didn't give you the equation. They only gave you the conjugate base. Do you see? They gave you this part here only. So for my brain, I took this conjugate base and I wrote what the acid would have been so that I can figure out cheerleading hands. So it must have been HF and it must have been HCl. HF is a weak acid, so the conjugate base has to be strong. HCl is a strong acid, so the conjugate base has to be weak. So which one's stronger? This one. Okay, so it's several steps of thinking to get to the answer. This is a tie for now. They're both weak acids. I'm sorry, they're both strong acids, which makes their bases weak. We'll figure out how to break that tie. And then here, one strong, one weak. So the weaker one is the stronger acid, okay? We are going to take notes on that white sheet of paper in thirds, like thirds this way. So if you're particular and you want it even, then you're going to fold it. If you're not particular, just like draw a line down 3 columns. And if you need a new sheet of paper, come get one. Our 3 headings are going to be acid, base, and salt. The math in the unit is not the hard part. It's just more ice tables. Like, you're going to get super good at it. You might even be able to solve an ice table just by pushing buttons. It's not the hard part. The hard part is categorizing them. So yesterday was the first time that we ever had to look at a molecule and know like how it's going to react, right? That was the first time that we ever like looked at it and we're like, okay, it's going to lose a hydrogen, it's going to gain a hydrogen. So that all is new. So now we're going to do that with actually 6 different things. So yesterday I pretty much put them in categories for you. Now we're going to start putting them in our own categories. So an acid is either going to be strong or it's going to be weak. Same with base, either strong or weak. And our salts, salt is just like a generic term for an ionic compound. Instead of saying metal and non-metal, we're going to say cation, which is positive, and anion, which is negative. Yesterday, it's like, I'm going to wean you off of that ion periodic table, and I totally take it back. I think we need it still. And I think we need it still because these are all going to be polyatomics that you haven't really seen before. And without that chart on the top of them, I think it'd be really hard for you to recognize what it is. So I take that back. We're going to still use it. Okay, strong acids. How do I know it's a strong acid? It starts here at chlorine. Sometimes you think HF. It starts with HF. It does not. It starts at chlorine. So HCl, HBr, HI. Then we have our chlorics and perchlorics, HClO4, HClO3. we have nitric, HNO3. And lastly, we do sulfuric, H2SO4. HNO3, H2SO4, which one? HClO3, HClO4. I have a jig-jag right through the middle of it. She's old. Okay, I'm going to turn the music on, memorization. So you're just going to say it to somebody twice, but alternate. So say it, hear it, say it, hear it. So you have time in between them. Say them twice to somebody. Make sure Jordan talks to somebody too. Go. Say it, hear it, say it, hear it, say it, hear it. These are the strong bases. They make the boots. Okay, practice them, but not by reading them, by looking at the periodic table. Record. Okay. If it is a strong acid, they are strong electrolytes. They completely dissociate. Dissociate means that they separate into their ions. That means like the water molecule magnets get up there and separate them. To practice that with salts. Completely dissociate means that the concentration of the acid, whatever it is, 0.1 molar, 2.0 molar, 0.75 molar, whatever that is going to be the same thing as the concentration of the hydrogens. They all got torn off. They're not the same thing, they're not the same molecule, but there's the same amount of them. The goal for this whole unit is to solve for pH. So once we know what that concentration is, we can just plug it straight into our pH equation and get the pH. P means negative log, so pH is negative log of the hydrogens. Remember, hydrogen and H3O plus are the same thing. Okay, same game for bases. They are strong electrolytes. So they completely dissociate to. Dissociate just means that they split up. The water molecule dipoles get all up in there. That means, though, that the concentration of the base, not boron, the base, whatever it is, 2.0, 0.1, 0.25, is going to be the same thing as the concentration of the hydroxides. They all split. They aren't the same physical thing, but the amount of them is the same. If we know this, we can solve for POH, because that's negative log of the hydroxide. And we know pH plus POH has to equal 14. So we can get to the pH from there. Okay? So let's do a sample problem with those. Get out your notes packet, and it's on the back of the page that we were learning yesterday. In this box here. Okay, so it says, what is the pH of a 0.028 molar solution of sodium hydroxide? The first thing that you have to do is put it into its category. So if we look back at this page, what category is sodium hydroxide in? It's a what? Strong base. So a strong base means that whatever that concentration is the same as the hydroxide, and we can solve for POH. So this is a strong base. The strong base means that the concentration of the base is the same as the concentration of hydroxides. They aren't the same physical thing, but they're the same amount. So that means that 0.028 molar is equal to this hydroxide. I'm going to let you do the rest with your battle buddy, but let's look at B. The 0.04 molar solution of HClO4, what category is that in? Can you HCl4, take a look at your chart. Strong acid. So that means the concentration of whatever that acid is the same thing as this. So 0.040 equals the concentration of the hydrogen. Okay, so with your data buddy, go ahead and solve for pH.